an angle is being bisected. Looking on your sheet, trying to figure out what type of reasoning you need to use. Probably, if you're not sure what to conclude, we can at least say we know we're going to use the definition of an angle bisector. Now maybe take a moment and pause the video and try to figure out what you're going to conclude, or find that and see what is its conclusion. What does that definition conclude when we know an angle is being bisected? But I'm going to keep going here, and I'm going to trace AC, so right down the middle, that's bisecting angle BAD. Well, that's that lower angle. A lot of students, when they read through both of these, will say, oh, BAD and BCD, they're the same because this angle up at the top is also getting bisected. But just because two things are getting cut in half doesn't mean those two things are the same. I could cut a turkey in half. I could cut a car in half. Doesn't mean the car and the turkey are the same. So don't assume that. When we're looking at that bottom angle, angle BAD, which two angles are the same? Well, if I would give you like 80 degrees, then this would be 40 and this would be 40. I mean, we don't know that, but you can see that it's 1 and 3. Those are the angles we're looking at. Those measures, measure of angle 1 and measure of angle 3, are going to be equal. And then when you look up at the top, which angles? Measure of angle 2 is going to equal measure of angle 4. And if that's all we had, well, we'd be stuck because I can't replace 1, 3, 2, I can't replace any of those. I don't have them equal to something else. Bisects, it bisects, but what about angle 1 being congruent to angle 2? Now, if you're thinking we're going to replace, you're probably right, but not quite yet. The replacement rule conditions are that two things are equal, that their measures are equal, which we're going to make sure that that statement, measure of angle 1 equals measure of angle 2, is there then, not just congruent, so that it satisfies the conditions for the replacement rule. Definition of congruent angles. Congruency means that the measures are equal. So if you have two things congruent, all of its measures are equal. Well, an angle, there's only one, so we say the one measure is equal. Now I have three equations. Still giving you some time to process here, trying to figure out, okay, how is this all going to fit together? And you can actually pick any one of those three equations and try to replace. If we pick the first one, measure of angle 1 equals 3, I could replace 2 for angle 1 and get 2 equals 3. And maybe replace 2 with 4 and get 4 equals 3. And eventually we could get there. However, there is one that can get us there right away. So it can get us there in one step. And that's the third one. So maybe pause the video and try to substitute in a third one and see if that makes sense to you. If we replace measure of angle 1 with measure of angle 3 because they're equal, and replace measure of angle 2 with it equals measure of angle 4, they're equal, in one step of replacing, I have the relationship between 3 and 4, which is really what I'm trying to prove. The only difference, I suppose, would be stating them congruent or naming them congruent rather than just knowing that their measures are equal. Which again, because we know what congruency means, all the measures have to be shown the same. Well, you only have to show one measure for an angle because there is only one measure of an angle. And by doing that, you've really essentially shown all the measures needed to be shown to know that they're congruent. So measure of angle 3 equals measure of angle 4. Well, then angle 3 is going to be congruent to angle 4 by the definition of congruency.